Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-1 Extra Practice Number 2 solutions on domain, range, and functions. On this problem, I want to know f of -3 and then f of 2. Those are the y values that I get if I use an x value of -3 and 2 on this graph. So let's take a look at f of -3. So looking at the x value, -1, -2, -3, and seeing where that falls on the actual graph here, we have an open dot at y equals -2. Since the function doesn't have a solid dot or a solid line there, the function's not actually defined there at all. So we would say that f of -3 is undefined. Now for f of 2, that's the y value at 2. Here's 1, 2 right here. We just want this y value here at x equals 2, and that's the y value 4. For this problem, I want to know the function value at these three different x values. So for f of 2, I'm asking what y value do I get when I plug in 2 for the x on this graph here. So going over to the x value 2, we see there is a y value right here that looks to be -4. So we'll say f of 2 equals -4. f of -5, looking at the x value, let's see, 1, 2, 3, 4, 5. We get a y value back of 0 right there on the x-axis. So that's 0 for f of -5. f of -1, here's -1 for the x values. Reading the graph here, it looks like we're at the y value for 2 for that one. So that's it. For this problem, I've got this function right here that I want to plug 3 into. So that means wherever I see an x in here, I'm going to replace that with 3. So 4 times 3 minus 5. 4 times 3 is 12, using a little PEMDAS here. And then 12 minus 5 gives me 7. For this problem, I want to plug a plus 5 into the function they gave me up here, 4x minus 5. So what I'm going to do is I'm going to take this x and I'm going to replace it, substitute a plus 5 in there. So I'll have 4 parentheses a plus 5 minus 5. And I need the parentheses so I don't lose anything. So now I'm just going to simplify this a little bit. I can distribute this 4 to the parentheses. That's going to be 4a plus 20. We still have that minus 5 kicking around though. So 20 minus 5 is going to give us a 15 over there. And that's as simplified as this function's going to get. For this one, I have 4x minus 5 as a function, and I want to do f of z squared minus 2. So this is basically saying take z squared minus 2, that whole thing, and plug it in for the x up here in the 4x minus 5. So instead of writing 4x minus 5, I'll write 4 parentheses z squared minus 2, all of that minus 5. Next, I'm just going to simplify by distributing this 4 and combining like terms. So I'm going to have 4z squared minus 2 times 4 is 8. Don't forget to subtract that 5 at the end though. So -8 minus another 5 is -13. So 4z squared minus 13 is our final answer. On this problem, I've got the function x plus 5, and I want to do f of 3m plus 3. Basically, this is just saying wherever I see an x, I'm going to substitute 3m plus 3 for that. So I'm going to rewrite this as 3m plus 3 plus 5. And then just combining like terms, 3 and 5 gives me 8, so 3m plus 8. On this problem, I'm trying to do f of p squared plus 2 for the function x plus 5. So basically, I'm just going to take p squared plus 2 and plug it in wherever I see an x in the function. So I'll rewrite this function as something plus 5, p squared plus 2 plus 5. No parentheses actually needed here, but I like to include it anyway, just to be on the safe side. Now we can combine like terms though. 2 plus 5 gives us 7, so p squared plus 7. For this one, we have the function f of x equals x plus 5, and we want to do f of x squared minus 5 quantity squared. So essentially, I have to take this x here. So initially, I've got something plus 5, and I have to replace that x with this x minus 5 squared business. So I'll just erase and replace. I'll write all of this x minus 5 squared stuff plus 5. Now, just a quick note that the x in here and this x in the original function are not necessarily the same x. This x up here is just kind of a dummy variable, they call it. It's just a place to store stuff, to insert things. Anyway, we have to simplify this a little bit here. So I'm going to have to expand this squared binomial. So I'm going to square the first thing, that's x squared, multiply these things together and double it. So x times -5 is -5x. Doubling that gives me -10x. And then squaring the second term gives me +25. And I still have that 5 that was out there initially as well. Don't want to forget about that. To combine this, I just have to add the 25 and the 5 to get 30. And then that one is going to be done. X squared minus 10x plus 30. On this multiple choice question, we're asking what g of -2 is, given that g of x is -5x squared. So essentially, whenever I see an x in the original function, I need to replace that with a -2. Now I'm going to be careful here and use parentheses around -2 when I do this. So I'm going to have -5 and then parentheses -2 squared. And at this point, let me use my PEMDAS. Exponents e comes before multiplying the m. So let me do -2 squared first, which is 4. And then -5 times 4 gives me -20. So that's going to be answer choice B. For this rather tricky question, I've got some constant c defined in this function here, cx squared plus 30. I don't know what c is, but it is a constant. Whatever it is, it's just that one number and nothing else. Given this function and the fact that f of 3 equals 12, they want me to tell them f of -3. So just kind of beginning with the goal in mind, eventually at some point we have to plug -3 into this f function and figure out what it comes out to. The problem, though, is that I don't know what this c value is right here. I could just leave it in terms of c, but they've actually given me enough information to figure out what c is. So I'm going to have to do that and give them an actual number. And I know I'm going to have to go further than just leaving this in terms of c, because if you look at the answer choices, these are all numbers with no c constant mystery in them. So to get this information, I have to first figure out the value of c, and I can do that by using f of 3 equals 12. This is saying when I plug in the x value 3, this gives me back an output of 12. So I can write c times 3 squared plus 30. This is again plugging in the x value 3 into this function. And I can say that that equals 12. F of x needs to be 12 whenever x is 3. So this is the equation I set up using this information up here. Now I'm just going to simplify a bit. 3 squared is 9, so this is 9c plus 30 equals 12. Subtracting 30 from both sides, we've got -18 on the right side. And then dividing by 9, we've got c equals -2. Now I'm going to go back and in order to find f of -3, I'm going to plug -2 in for the c value right here, and then I'll plug in -3 for all that. So I can write f of x equals -2x squared plus 30. So then f of -3 is going to be -2, that was our c value here, times the x value -3 that they wanted me to plug in, and I'm going to square that and add 30. So PEMDAS, we've got -3 squared, that's going to be 9. -2 times 9 is going to be -18. And then -18 plus 30 gives us +12. So that's going to be answer choice D.